guys, how you doing? I thought you might be interested in this. I'm just discharging one of these batteries. So you know I'm using these drill batteries at the moment, these Bosch 36 volts. Using them there, you can see there's all 4 of them. So because I'm pushing them pretty hard, I thought I would do a discharge test on one of them. I had trouble saying that then. I'd do a discharge test on one of them just to basically see how much capacity is basically left. I mean, they're probably, I don't know, I don't think they're a year old, but I've pushed them pretty hard. Using them in the quad bike, using them on the e-bike as well, and now I've been doing quite a few cycles, literally. So let's see. So total time it's taken. This is just my lamp. I think I'll just move that out of the way because it's just getting in the way. Right. So 160 minutes it took. I can only do a 2 amp discharge on this charger, and also because of these thin little wires. So I think if you scroll through here, 5469. So 2 amp hours, 5469, and they are supposed to be 6 amp hour batteries. So that's lost a bit of capacity, if that's correct. So it was fully charged. Obviously, I'm not going to do the charge test on this because I can't balance them whilst I'm charging, and then that wouldn't be a fair test anyway. But yeah, it looks like 5469. Yeah, so it's probably come down a bit from what it was. I mean, this is only at 2 amps as well, so that's quite interesting. So it's definitely taken a bit of capacity off of them. I didn't test them from new though, so this is another one. What I'll have to do is have to try cycling another one and just see what happens there. Perhaps I'll do that tonight because I'm going to get this one charged up and then I can use it again on the bike. Let's put that back on the charger. All looks okay. Let that run, and then I'm going to put take this one and discharge this one and just see what's left in this. So they start off about 41.6 volts, these batteries, off the charger, and they drop a bit. I think they're around 41.8, and then they drop to about 41.6. So I'm going to plug this one in. So I just wanted to double check my discharge was 3 volts a cell. It is, so there you go. Right, it's all wired up again. We can go discharge, no balancer, because we like to live life on the edge. Select cells, 10 cells. So yeah, it said 41.5 there. My dodgy meter from the pound shop probably said 41.6. So right, that's discharging now. So in hopefully another 159 minutes, that'll be about the same. Otherwise, that one could be a dodgy pack. I reckon they will all be the same, to be honest, because the meter shows exactly the same at the end of a discharge. You know, when pulling them pretty hard, the meter's saying exactly the same, like 1 bar or 2 bars. Sometimes I finish on, and they're all exactly the same voltage. So I'm not expecting the capacity of the others to be any different. I expect them all to be probably the same. But it's interesting to know that. So basically, you know, that's not even 11 amp hours of capacity running on that e-bike. I mean, that's doing me fine. I mean, I'm not finding like I'm running out of power. I'm getting bored before I've run out. Well before I've run out. So there you go. But anyway, we're talking about this new battery pack. The reason why I'm doing these tests now because I just wanted to see. But I'm talking about building a new battery pack out of LG cells, either HE2s or HE4s. I think HE4s. So I'll keep you posted on what's going to be happening with that. Looking at a new BMS as well and how to do that. So it's going to be quite an interesting journey. I'm going to get that built up hopefully before summer's out, and then we can still enjoy some of this weather with that new battery. So stay tuned and I'll keep you posted. Right, just come back in, still going strong. Only down to 33 volts. 3.3 volts a cell, still ticking up, 4,400 milliamp. That should go for another, well, if it's anything like the last one, it should go for another half an hour. Right, here we go guys, moment of truth. It's ended on pretty much the exact same time, 159.54, 5486. So 5469, 5486, pretty much exactly the same. So it's encouraging that they're all exactly the same. Well, these 2 packs are the same. I should imagine the other 2 are going to be exactly the same because they end at the same voltage. All 4 of them end at exactly the same voltage. So interesting, isn't it? Definitely peace of mind knowing that you're getting exactly the same from each battery. So one particular battery is not going to discharge quicker than any of the others. Obviously 2 won't because, well, the 2 banks won't because they're parallel, so they become one battery. But yeah, interesting stuff. It also shows we've lost a bit of capacity because we're like hammering the batteries a little bit harder than they're probably designed to do. But the thing is, they're coping with it. They're coping with it absolutely fine. All that's happening is the capacity is obviously reducing. Now, I never measured these batteries. Oh, loud plane. As I was rudely interrupted. Now, I never measured the actual batteries when they were new, so I don't know, you know, their exact capacity. They might have been slightly down anyway. I mean, the charger might not charge them fully. I think it does though, because it does take them to about 41.8. So yeah. Anyway, guys, hope you found this interesting. Just a short one, just to show this, because I was just wanted to find out what actually really happened when I did a test like this. I mean, I could have actually done a graph. This thing connected to a computer can actually draw graphs as well, but you know, this is just a quick test, guys. Anyway, hope you enjoyed the video, and I'll catch you in the next one, guys.